Okay, hi everybody, welcome back to the Redbridge Science channel. Today we're going to be looking at the reactions between metals and hydrochloric acid. So similar to last time when we were looking at water, today I'd like you to be able to plan a fair test to prove which metal out of copper, magnesium and zinc reacts the best with hydrochloric acid. So before I show you the experiment, there are three variables that I want to remind you of. First of all, the independent variable. So the independent variable is the one thing that you are investigating, okay? Independent, investigate, okay? And in this experiment, we are talking about the type of metal. Which metal? Copper, magnesium or zinc. There are going to be control variables, things that we must control to make sure that what we're doing is a fair test. And finally, there's the dependent variable, and the dependent variable depends upon the independent variable. It's essentially the result. Okay, so I'm going to put my goggles on for this experiment this morning, and what we've got is the type of metal. So we've got three today. We have copper, we have zinc and magnesium. Okay, so the first thing I've done is control it, is to make sure I've got the same amount of metal. The second control variable is to try to make sure I've got the same volume of hydrochloric acid. Okay, so we've already prepared the three test tubes and labelled them with copper, zinc and magnesium. So I'm going to put 5 centimetres cubed of hydrochloric acid into each of these. And okay, so let's first of all put our copper into here, and let's have a look and see whether this is going to react with hydrochloric acid. I'm going to bring it up closer to the camera. I was going to put my grey behind that just to see if that will help you to see if there's any reaction going on. So what am I looking for? I'm looking for any signs of a reaction. Is there a colour change? Are there any gas bubbles? Looking to see, is there any heat coming off? Nope, nothing much seems to be happening there with copper. Okay, zinc. Zinc into the hydrochloric acid. Now again, looking for signs of a reaction. So not seeing a huge amount going on there. Sometimes with zinc you get a few gas bubbles. Ah, there we are, there were a few there. Give that another shake in a second. Let's just see whether we can get any more gas bubbles. Yeah, okay, so it is just starting to react very slowly, admittedly, but there are definitely a few gas bubbles there. So there are some signs of a reaction, just not a great one. And finally, let's try magnesium with hydrochloric acid. Okay. Now, hopefully, you can see that straight away. Okay. Lots of gas bubbles. Now, the magnesium is also beginning to dissolve. Okay. And the other thing I'm going to do is going to check, yeah, that's really quite hot. So this reaction is called an exothermic reaction. It's releasing heat. Heat is exiting into the surroundings, so that's quite hot. So there's some clear signs of a reaction there. And what I'm going to try to do is collect some of this gas. Now, before I do this test, I will warn you, it's a bit unreliable. Sometimes it works and sometimes it doesn't. We had a practice go just now and it didn't work, so we'll see. But this reaction between magnesium and hydrochloric acid is releasing a gas, and maybe you'll be thinking about what gas that might be. The clue could be in possibly the name hydrochloric acid. And maybe, if you are thinking about what that gas could be, this will be the clue, because in a moment I'm going to test it using a burning splint. Okay, now as I say, this may or may not work, but let's just see whether we can get this gas No, it doesn't want to. But what I was hoping was that you might have heard quite a loud pop sound then. And the popping is because the gas that's being produced there is hydrogen gas. And hydrogen is a very flammable gas. Okay? So I'm sorry about that. It's just not been very reliable today. But hopefully you've seen... In fact, I'm going to show you the zinc again, actually, because that has now reacted. You can hopefully see the gas bubbles there a little bit clearer. Again, I'll give them a little knock. Okay, so you can hopefully compare the reactions back to the copper. No, still doesn't look as though it's done anything there. So, in a moment I'll be setting you some tasks to go with this film clip, okay? Remembering that what we're trying to do is, were you able to plan a fair test, and are you able to now look at those three results and decide which of those metals has reacted the best and which one has reacted the least with hydrochloric acid? Okay, thank you.